Okay, I'm Bill Freeman. I'm a professor of electrical engineering and computer science at MIT, also a member of CSAIL. I'm the moderator. I'll introduce the speakers, and then I'll ask questions for the panel discussion afterwards. Each of them will give an 8 to 10 minute talk, and then we'll ask them questions for 20 or 25 minutes. So the topic is generative AI foundations. The first speaker is Jacob Andreas. He is a professor of electrical engineering and computer science at MIT and also at CSAIL. He will be talking about generative models of language.
Great. Thanks, Bill. So I want to start by just, sort of thinking briefly about the state of current technologies for doing language generation. This is a snippet of a conversation between the New York Times reporter Kevin Roose, a conversation between Kevin Roose and Bing Chat, a sort of chat-based search engine that Microsoft released. The snippet comes, hours into this conversation, and this chatbot is appearing to talk about its real self, its emotions. It goes on to try to convince the reporter to leave his wife and run away with the chatbot instead. And this is something that we can do with sort of modern language models. Here's another example with a slightly different flavor of a related system from Google, taking in a sort of complex description of a complicated programming problem and mapping it to a chunk of code that actually solves that problem. And I really want to emphasize that when I started grad school just about 10 years ago, this was science fiction stuff. I think it was totally unimaginable that we'd be sitting here in 2023 with systems that could sustain long, sort of coherent-seeming conversations and solve complicated programming problems like this. So how did we get here? And to sort of set this up, I want to start by talking a little bit more precisely about what these language generation systems are. And Rod talked about a little of this in the first talk, but fundamentally what these things are next token prediction systems, or word prediction systems, right? Just like the one that sits on your phone when you're writing a text message that tries to guess what word you're going to say next. And so they take a bunch of words as input, they pass it through some sort of big statistical model called a language model, and they produce as output a guess about what word is going to come next. Now, almost all of the big language generation systems that you see today, ChatGPT, any of these search-based or chat-based search engines, whatever, are based on a particular neural network architecture called a transformer. The details here are not all that important, other than that these things are easy to train, computationally efficient to train at a very large scale. And what that means in practice is that we can train them now not just, say, on all of the text messages that you've ever sent, but all the text on the internet, or maybe even more. But it's worth noting that this is not actually fundamentally new technology, and that language models in some form or another have really been with us since like the end of the Second World War, where they were part of code-breaking systems. And we've gotten here gradually over a bunch of technological developments in the last 10 years or so. So why is it that just learning to do next word prediction builds these sort of surprisingly capable models? And sort of fundamentally, the intuition here is that in order to get really good at guessing what word is going to come next in an arbitrary piece of text, you need to learn some things about language, right? You need to learn rules of grammar and how to make verbs agree with nouns and things like that. But you also need to learn things about the world. You need to know that people in general are more likely to say things that are true than things that are false, and therefore need to have access to some model of the facts in order to guess what kinds of factual statements are likely to be made. And this includes not just sort of trivia and factoid knowledge and things like that, but really common sense physics and other seemingly more basic pieces of understanding. And once you have all of these capabilities, those are really what give you the ability to do these kinds of open-ended text generation problems, to do things like follow instructions that are communicated in natural language, and to predict as output what's going to come next. But the really fundamental thing to notice here is that in the course of getting really good at modeling language, you have to be a good model, not just of sort of the rules of language, but at least in some sense a model of the rest of the world as well. So how should we expect things to change in the next couple of years, and what does it even take to get to this point? One really important thing that I want to emphasize is that there haven't actually been fundamental changes in the underlying technology that we're using for these language generation systems, really since around 2018 or 2019 when these transformer models first came out. And what's changed in the interim is just that we're training larger and larger versions of these models on more and more data. So we're showing on the vertical axis here is the parameter count of the biggest model in a given year. You can think of this as roughly a measure of processing power. And we've gone in 2019 or 2018 to models with 100 million parameters to models with hundreds of billions parameters, or maybe even more than that. And these are the models that really produced all these examples that we've been looking at in this talk. So what does it take to build a model at this scale? It takes time, right? These models take months, maybe even a little bit longer than that now to train. They take enormous amounts of data, including, both in practice, sort of all of the data that can be scraped from the internet and a bunch of hand-curated data that people are being paid to collect. Specifically for the purpose of training these models. It takes money, hundreds of thousands of dollars, maybe tens of millions of dollars, maybe billions of dollars for the very largest of these models. And this is something that I think is really important when we're sitting here at academia, thinking about the implications of this for what kinds of research problems academic researchers can solve if we don't have the billions of dollars to train these models in individual labs. And finally, it requires a bunch of specialized expertise. This is now a sort of new kind of engineering discipline that hasn't really existed before, that isn't part of our standard machine learning or computer science curriculum, and something that I think we're still figuring out how to teach. And the last thing that I want to talk about is sort of how we expect things to change maybe even more fundamentally in the future. Everything that I've been showing up to this point, including training these big models themselves, is sort of business as usual from a machine learning perspective, right? We're training sort of big neural network models that we've had since the 60s, using algorithms that we've had for centuries, if not decades, and I think one of the most important things that's going to happen as we move into the sort of era of large language models, or as we find ourselves in that era, is that there are going to be more fundamental changes in what machine learning looks like fundamentally, right? Because once we have systems that can do things like follow instructions, that can answer questions, that can maybe even ask questions on their own in order to gather information, we gain the ability to train systems not just by going out and collecting big labeled data sets, not just by sort of doing free interaction with the world in a normal reinforcement learning sense, but in a way that looks more like the way that we teach people, by talking to them, by giving them rich feedback in the form of language or other forms. And it's important to note that this is not just for training systems that can process language, but machine learning models of all kinds. So hopefully this will both play. These are actually two examples from MIT of systems that are learning with side information from humans how to solve household tasks, how to sort of interpret a demonstration to avoid stepping on a laptop and things like that. And maybe more interestingly than this, right, these are cases where a person stepped in and told a model to behave in a particular way or explained a particular solution to a model. Here are some examples of a system that we built in my group where the model is actually collecting its own data. It's going out to a user who has a task in mind but doesn't quite know how to formalize that task and asks that user questions in order to help them build some sort of machine learning system for the task of interest and get the data that they need. And this, I think, represents a more fundamental change in what ML looks like and what we think of as ML, and is one that I'm particularly excited about. The last set of things that I want to talk about here are the implications of this, maybe not for machine learning, but for human learning. And another big direction that we're excited about, and one that I think there's going to be a whole day of this generative AI thing on, is education, and the possibility of now using these tools to help human learners acquire concepts that maybe the model has and the human doesn't have. So here's an example of a sort of automated tutoring system. But maybe more fundamentally than that, we can use these models to help us, not just as sort of new learners, but maybe as sophisticated scientists, to learn something about our models themselves. Here's a system that actually labels, when Rod was talking about those embeddings before, labels individual pieces of those embeddings with descriptions of what they do in natural language, using a learned model itself to sort of be a scientist and inspect the model and figure out what's going on. And maybe last and most importantly, and this is work that I'm doing with a bunch of other people in this room, including Antonio and Daniela, is the possibility that we might be able to use these kinds of sort of sophisticated learning systems to actually help us answer basic scientific questions about the natural world. Here's a big project about sort of using training language models on data sets of whale communication and using it to understand something about how sperm whales interact with each other. So I think to sort of wrap up here, we really are going to see fundamental changes not just in the kinds of capabilities of, or rather that we see in the systems that are deployed, but maybe in the way those systems are trained and produced in the first place, moving towards a world with much richer forms of feedback and a world in which we train AI systems in a way that looks a lot more like the way that we train people. And I'll wrap up there.